Hello and welcome back to another video. In this problem, we're looking at the table here with a bunch of values for relating x and y. We're asked which of the following equations represents this scenario. So if we notice, we want to look for the rate of change, right? We want to see how much does it change as you're going from one x value to the next. And so we can say, okay, we have evenly spaced x values, right? So we're going from 1 to 2, 2 to 3, 3 to 4. So every single one of these is just adding 1. So if we are looking for the change in y in the same pattern here, then we can narrow down our options, right? Because if we want to find the equation of the function here, we cannot do it by plugging in 2 points. If you know that it's linear, you can plug in some points and find the equation. If you know it's exponential, you can plug in points. But until we know whether it's linear or exponential, we cannot find an equation. Because let's say this is exponential, and we plug in these 2 points, thinking that it's linear. Well, there is a line between these 2 points, so you're going to find an equation, but it's not going to be representative of all 5 points. So what we're doing is, since we know that we have even spacing of x here, if we have even spacing of y, then it's linear. And if we don't, if it's changing over time, the distance between them, that means it's exponential. So the difference from 1 to 2 is 25 over 4 minus 11 over 4. We have the same denominator here, so you just subtract the numerators and you get 14 over 4. So our change is 7/2. From 2 to 3, we have 39 over 4 minus 25 over 4. Similar situation, subtract the numerators and you get 14 over 4 again, which is still equal to 7/2. And if you do a similar thing, 53 over 4 minus 39 over 4, also equal to the same amount. And finally, 67 over 4 minus 53 over 4. It's all the same. So we know that as x increases by a constant amount, y is also increasing, so therefore it's a linear equation and we can eliminate a and b. Looking at c and d, they have different slopes, so all we have to do is find the slope of this relationship when graphed in the xy plane, and we'll have our answer. We don't have to check for the y-intercept of the line. So we've kind of already done that, right? So the slope is equal to the change in y over the change in x. And we've just found that when you change x1, so going from 1 to 2, that's changing x1, y changes by 7/2, right? It changes from 11/4 to 25/4, that's a distance of 7/2. So our slope is 7/2 over 1. Well, anything divided by 1 is itself, so your slope is 7/2, which lines up right here with D is going to be your final answer.